Hey there, we are looking at this problem balanced binary tree. Given a binary tree, determine if it is height balanced. What does it mean by height balanced? A height balanced binary tree is a binary tree in which the depth of two subtrees, the left and the right, of every node, not just the root but every child node, differs by not more than 1. So the maximum difference between the height of the left and the right subtree should be 1. Let's take an example. Let's look at this node. The left subtree has a height of 1. The right subtree has a height of 2. The difference is 1. If it is 1 or 0, that is an acceptable value, which means this particular node is height balanced. But we need to check every other node too. So for 9, the left and the right subtree would be height of 0 and 0. Maximum difference is 0. From over here, it's 1 and 1, maximum difference of 0. From over here, it's 0 and 0, maximum difference of 0. From here and here, the difference is 0, which means that the maximum difference on any node is 1. So this one is a height balanced tree. Let's take another example. Looking at this, for the node 1 in this example, the height on the left side is 3 and the height on the right side is 1. So the difference is 3 minus 1, which is 2. Now this tree is not a height balanced tree. Now that we understand the problem, let's take a look at the approach to its solution. A naive approach we can think of is, how about in this subtree, we go to every node and calculate the height. From the root node, we calculate this height. And from the root node itself, we calculate this height. Then we come over here, we calculate this height, and we calculate this height. And we do that for every other node. As you may have noticed, we are solving the same problem again and again. If we are at this node, we are calculating this height. And when we are at this node, we are still calculating this height. So how about we not calculate the same distance again and again, but calculate it just once? So currently we are calculating heights for every node, which mean n node, and we are calculating their height. So that would be log of n, which means we have an algorithm of n log n. Can we make it better? Yes, there is a way. How about we use DFS algorithm on it? Instead of calculating this height every time, how about we go in the reverse direction? How about we calculate the height from here, which would be 0, and then we come over here, we say 1, and then next time any node needs an information about the height at this place, we return it from here. So this would be 1, this would be a 0 height, and this would get a height of 2. In this case, we don't have to calculate this height again and again. And that's what we are going to do. We would first go deep into the tree and then come back. And we would return the height from every iteration. Now, this solves one part of the problem. We have another problem. How do we find out that a subtree is not height balanced? For example, let's say this, we have this configuration, which makes this tree not balanced. So how does the node over here finds out that we have received a height unbalanced tree as a subtree? How do we pass that information? So earlier we were thinking of passing on the height information from one node to the another. From here, we would pass on the height information, and this particular node would add 1 to it. This would be a height of 2. From here, 1 plus 1, this would be a height of 2. And over here, it would add plus 1 again, so it would be a height of 3, and this side it is just height of 0. How do we pass the information that this subtree is not balanced? So what we can do is, instead of returning height, we can also return a flag. So we would return both height and a flag. In a normal scenario, it would be a positive height. Otherwise, we would return -1. In our case, a -1 height cannot exist, which means we can use -1 as a flag to figure out if a subtree is height unbalanced. And if it is unbalanced, we can simply return -1 from over here. We don't need to really calculate all of this. We can say if this subtree is height unbalanced, this entire tree is height unbalanced. So now to better understand this problem, let's take a look at the code. I'm in the code editor over here. I have given this function is balanced. It is accepting a root and it returns a bool. For true and false, if it is true, we are height balanced. If false, we are not balanced. I would like to create a function over here to perform depth first search. DFS, it accepts a root and it returns an int, which would be the height. Let's calculate the height of the left subtree. Let's call it left height equals to self dot dfs root dot left. Similarly, right height equals to self dot dfs root dot right. These would give me the left height and the right height. If the left height, let me correct the mistake. If the left height is equals to -1 or the right height is equals to -1 or the difference of left height and right height is greater than 1. In this case, I have a height unbalanced tree, which means I should return -1. The subtree or the current tree is height unbalanced and I should return a -1. If this is not the case, I should return the height, which would be the maximum of the left height or the right height and adding its own height, which is +1. This would give me either the height or -1. Let's check it. If DFS, I'm passing root. If this is equals to -1, let me return false. We do not have a balanced tree. Else, return true. Let's try to run this code. So, okay, I have a typo here. Okay, we are not checking for the null condition here. So if not root, return the height at the leaf node. So that would be 0. There is no height after the leaf node. The leaf node has a height of 0. This is passing. Let's submit it. We have a solution.